Yeah, good morning everyone. Myself, Shaik Imamvali. I am the Associate Professor in the Department of ECE, Kumburi Pratap Reddy Institute of Technology. Today I am going to explain you about the microcontroller subject. In that microcontroller subject, I am going to discuss about Unit 3, which is related to input-output peripheral devices for interfacing of 8051 microcontrollers. Okay, in this units we are going to discuss about displays, LEDs, LCDs, and then we'll discuss about keyboards, and then we'll discuss about external memories like RAM, ROM, how we are interfacing this to 8051, and also we'll discuss about the analog to digital converters and digital to analog converter interfaces to 8051. So first of all, what is the display? Before we are going to know about what is a display, what is going to show in display. So whatever the input which we are giving, it is we can able to see in the display. So the input which we are using as keyboards as a predominant interface of human input. So whatever the electronic components which you have taken, then obviously the input of human which will be given through the keyboards, and then whatever we are going to visible as a display, those are the universal means of human outputs. Okay, so this human output, we can say it as display. These displays are classified into three types basically. One is single light, and another one is single character, and the third one is intelligent alphanumeric display. So we will discuss one by one. So first one is single light displays. So this single light displays, we can call it as manner indicators. So which is having only two options, either it may be on or either it may be off. And this single light displays can be used as a LEDs or incident bulbs or single characters or numerical numbers or alphanumeric arrays. So we can use all these things in the intelligent alphanumeric displays, like in the microcontroller we can use ASCII codes, and in the 7 segment display, which is consisting of 7 LEDs to form the 8 shape to see the display digits. And this displays can be either it may be common anode or common cathode types, depending on how we are going to be wiring. So when comes under multiple displays which we are going to use, so this multiplexing is should be quickly visible. And if it comes under the single character displays, can be it is as simple as a 7 segment displays or advanced intelligent numerical LCDs. So to operate these LED segments, we need minimum 10 milliamps of current. Sometimes the cathode may lead 70 milliamps, and these microcontroller programs handle segments lighting using ports, and these ports which are there in that integrated component, those are 8051. So this 8051 microcontrollers having some ports. So these ports, maybe three ports are there: port 1, port 2, port 3. So these ports we can able to connect this displays, and whatever the program for each segment which is available in the lookup table, this lookup table will be existing in that memory. So for each segment, for suppose if you want to display 0, then the binary code of this 0 will be available in that lookup table. So automatically whenever we want to display that 0, then this process, this controller will fetch the code from the lookup table which is available in that memory, and the main program provides the number data, while the interrupt driven routines manages display updates. Okay, so what we are doing here, the main program whatever we want to provide to the data, and interrupt driven, so ISR will be there, interrupt service routine, like, and so this will manage display updates, whether it is to be delay or we have to keep some results, or how much time it should be on, what is the difference between each segment changing from one digit to another digits. So all this will be handled with the interrupt driven routine. So this is the basic segment patterns of 7 segment display. Here we can able to see 7 segments: A, B, C, D, E, F, G. Or suppose I want to make one as enable. For that, what I want to do, I want to write the code B and C as 1. The remaining all I have to be make it as a 0. So don't we think that if I enable only B and C, then it can able to show the segment of 1. But we have to be consider, and we have to be disable the remaining segments. Otherwise, the existing program or the existing bit value may be stored in that segment, so that it may not be, we cannot able to see the exact segment value. So that is the reason whenever we are going to write the code for any segment, we have to write for all the 7 segments, then only it will be work on it. So this 7 segment display is connected to some IC, either it may be 8051 or 8086, any microprocessor, microcontroller. So this need the crystal oscillator of 11.0592 MHz. Approximately 12 MHz crystal oscillator will required to operate this segments, 7 segment displays. So this crystal oscillator will make the performance, how fast it is going to be display, and what is the minimum range, how much time it should be on, and all. Operating frequency we can call it as operating performance, we can say, based on this crystal oscillator. Clock speed, we can call it as clock speed as well. So based on its speed, this display will be functioning. Okay, so this is a circuit diagram of 7 segment pattern. So here we have used 8 diodes, light emitting diodes, for different characters. We have used different diodes. So this is the program how we are going to write for this 7 segment display. We'll continue this programming part in the upcoming video. Thank you for watching.